Hey everyone, welcome back to the deep dive. For today's deep dive, we're actually taking a look at something pretty personal. We're talking about your own voice.
Yeah,
Yeah, it turns out that your voice can actually reveal a ton of information about you, especially when it comes to something, well, kind of crucial like your cognitive health.
that's right. And that's where this whole fascinating area of vocal biomarkers comes in. You see, it's not just the words you say. It's the subtle, like the really minute characteristics of your voice that can offer these surprising clues about what might be happening in your brain and get this, maybe even years before traditional methods would pick anything up.
Yeah, and you send over this blog post laying out the science behind these biomarkers, which was, I gotta say, a pretty eye-opening read. And that diagram, the one showing vocal fold motion impairment, that was super helpful too. But okay, let's get down to business. Our mission here, right, is to really dig into these vocal clues and figure out what they could mean for, both understanding and hopefully even outsmarting cognitive decline. So where do we even begin with this whole voice-brain connection? Like, how are they even linked in the first place?
Well, I think the first thing to really grasp is that speaking, it's not just about choosing the right words and putting them together in a sentence. It's like a wildly complex biological symphony happening in your body every time you open your mouth. I mean, you've got your brain, obviously, but also your nervous system, your respiratory system, and those incredibly delicate vocal folds in your larynx all working together with absolute precision.
You're absolutely right. And that diagram, seeing those vocal folds vibrating hundreds of times a second just to make a sound, it really drives that point home. We kind of take speaking for granted, but it's this mind-blowingly intricate process.
Precisely. And because it's so intricately coordinated, with all these neural signals zipping back and forth from the brain, even tiny, and I mean minuscule, neurological changes can throw off that delicate balance. And the really wild part is that these subtle disruptions can actually show up as these microscopic variations in how your voice sounds, changes that neither you nor the person you're talking to would ever consciously notice.
Okay, so we've got these subtle shifts in our voice. But what kind of scientific evidence is there that actually links them to, what's happening cognitively?
Well, there's a whole mountain of research emerging that points to a pretty strong link here. You remember that Framingham Heart study we discussed?
Yeah.
That massive long-term study that's been tracking health data for decades.
Yeah, vaguely.
Well, they discovered that 14 distinct acoustic features in people's voices were significantly associated with their risk of developing dementia later on. And one of the strongest predictors they found was this thing called jitter.
Jitter. Wait, isn't that just those little variations in pitch, like how much your voice wobbles?
Yeah, exactly. Those little almost imperceptible fluctuations in pitch. But get this, they can actually tell us a lot. I mean, researchers were able to create a computer model that could predict who would develop dementia based on these voice characteristics.
Really? And how accurate was it?
Well, it had an AUC of 0.812.
Okay. For those of us who aren't statisticians, what does that actually mean?
Basically, AUC scores range from zero point 0.5, which is like flipping a coin, pure chance, to 1.0, which would be a perfect prediction. So 0.812, that's pretty darn good. In fact, as that blog post pointed out, it actually outperforms some of the standard cognitive screening tests we're using today.
Wow. So potentially, the way we speak could be an even better early warning sign for cognitive issues than some of those, pen and paper tests. That's a pretty big deal.
Yeah, that's exactly the exciting potential we're talking about here. And the evidence just keeps getting stronger. Remember that 2023 study mentioned in the blog post, they found that vocal biomarkers, specifically the words people used and the acoustic features of their voice, were actually better at detecting mild cognitive impairment than a very commonly used test called the Boston naming test.
So it's not just about the sounds, but also the actual words we're using.
Precisely. They called the analysis of the words lexical semantic, and it actually had an AUC of 0.80, while the acoustic features had an AUC of 0.77 compared to the Boston naming test, which only had an AUC of 0.66.
Those are some pretty striking numbers. Our voice is clearly holding on to a lot more information than we realize, especially when it comes to those early stages of cognitive change. Now, the blog post also mentioned that these vocal biomarkers aren't limited to just Alzheimer's, right? They could potentially offer insights into other neurodegenerative conditions as well. And I think this is a good time to bring in that diagram we were talking about, the one about vocal fold motion impairment.
Absolutely. While the research on Alzheimer's is definitely promising, the potential here really spans a wide range of neurological conditions. And yeah, that diagram illustrating vocal fold motion impairment is really helpful here. It shows how different underlying issues, whether it's a neurological disease or something else, can lead to either one-sided or two-sided impairment of the vocal folds, and that can result in specific changes in how someone's voice sounds.
So the way our voice changes could potentially point to not only that something's happening neurologically, but maybe even give us clues about what kind of neurological issue it might be.
Exactly. Think about Parkinson's disease, for example. Researchers have noticed some pretty distinct vocal patterns in people with Parkinson's. They tend to have reduced pitch variation, which gives their speech a kind of monotone quality, and you'll also hear increased breathiness and imprecise articulation. What's really interesting is that one study was actually able to identify these Parkinsonian speech deficits in people with REM sleep behavior disorder with about 70% accuracy.
Wait, REM sleep behavior disorder, isn't that where people act out their dreams?
Right, and it's often a precursor to a Parkinson's diagnosis, sometimes years before the typical motor symptoms show up.
So you're saying we might be able to identify someone who's at higher risk for Parkinson's years in advance just by analyzing their voice. That's incredible. What's the connection there, neurologically speaking?
Well, the blog post explains that it likely comes down to dopamine, or rather the lack of it. Dopamine is a neurotransmitter that's crucial for movement, and in Parkinson's, you have this depletion of dopamine. And that doesn't just affect large movements, it also impacts those very fine motor controls that are needed to make your vocal cords work properly. So that's why you see these characteristic changes in their speech.
Makes sense. And what about multiple sclerosis? I remember the blog post mentioning that it has its own unique vocal fingerprint.
Yeah, that's right. MS tends to affect vocal patterns in a different way than Parkinson's. Some of the hallmarks are problems with the timing of articulation and how breathing coordinates with speech. For example, researchers have looked at things like how long unvoiced stop consonants like P or T last, and the way unvoiced fricatives like N and C's kind of fade out. These are all subtle clues, but they point to the impact of MS on the neural pathways that control speech.
So it really does seem like each of these conditions has its own signature in our voice, which pretty amazing when you think about the possibilities for early detection. Now, that blog post also talks about a company called Vibes AI and their mission to use all of this to help prevent cognitive decline. Can you tell us a bit more about what they're doing?
So, Vibes AI is really on the cutting edge here. They're taking all of this research on vocal biomarkers and turning it into practical tools that people can use to monitor their own brain health. And get this, they're actually developing different approaches for different personality types.
Really? That's interesting. One size fits all rarely works when it comes to health and technology.
Yeah.
So tell me more about these different approaches. I think they mentioned something about questioners, obligers, rebels, and upholders, right?
That's right. So for questioners, the folks who love data and need to understand the why behind everything, Vibes AI is building what they call a cognitive insight engine. It'll give users detailed analytics on their vocal biomarkers, tracking a bunch of different acoustic and linguistic parameters over time. The key is that it explains what the changes in their voice might mean in terms of their brain health, with things like confidence intervals and comparisons to their own baseline. Basically, it's all about the data and the logic behind it for this group.
Makes sense. And what about the obligers? How are they going to get those folks on board?
Well, obligers are all about accountability, right? So Vibes AI is creating an accountability partner app for them. It combines the vocal biomarker monitoring with things like reminders to use the app, scheduled check-ins, and the ability to share their progress with friends or family. It's like turning brain health into a team effort, which is perfect for them.
That's a great idea. And the rebels. How do you design something for people who don't like being told what to do?
Yeah, that's a tough one. But Vibes AI has got it covered. Their Freedom Tracker app gives users complete control over their data. They can see their vocal patterns, learn about potential connections to brain health research, but there are no mandates or recommendations. It's all about giving them the information and letting them decide what to do with it.
Love it. And what about upholders?
Well, upholders love structure and routine, so they get the cognitive discipline system. It lets them integrate the vocal biomarker monitoring into their existing brain health routine, setting their own schedule, adding their cognitive exercises, and tracking everything in one place. It basically helps them stick to their plan, which is exactly what they need.
It's amazing how much thought they've put into this. So we've talked about early detection, but it sounds like vocal biomarkers could also be used to guide personalized interventions, right? I think the blog post mentioned something about that. How would that actually work?
You're right. The really powerful thing about vocal biomarkers is that we can use that information to create interventions that are tailored to the individual. One example is something they call restorative audio therapy. Basically, they analyze your vocal biomarkers to identify specific sound frequencies and patterns that might help boost your brain's plasticity, its ability to change and adapt. Then they can create these personalized sound therapy sessions designed to target those specific areas.
So it's like using sound itself as medicine, but in a very precise way. I love it. What was the other example?
The other one was music therapy precision. Now, we already know that music can have a huge impact on the brain, but different types of music affect people differently. The idea here is to use vocal biomarkers to figure out which specific musical elements, like the tempo, frequency range, or harmony, would be most beneficial for a given individual.
So it's all about moving away from these generic recommendations and creating truly personalized treatments based on what our voice reveals. It's pretty mind-blowing. And the blog post also made a connection to the Lancet Commission on Dementia Prevention and those 12 modifiable risk factors, didn't it?
Yeah, it did. And that's a really important point. The Lancet Commission identified 12 key risk factors for dementia that we can actually do something about. And Vibes AI's system is designed to look for clues in your vocal biomarkers that might be related to those risk factors. Then it can recommend specific lifestyle modifications to target those areas.
Do you have any examples of how that might work in practice?
Sure. For example, let's say someone's voice analysis shows subtle changes in their vocal timing that might suggest some early issues with executive function, those higher level thinking skills like planning and decision making. The system might then recommend personalized exercise routines that include both aerobic and strength training, which have been shown to be particularly good for the frontal lobe, where a lot of executive function happens. Or maybe the analysis shows shifts in their language complexity that could indicate some early changes in semantic processing, their ability to understand the meaning of words. In that case, the system could suggest activities focused on vocabulary building and language-based tasks. Or if their vocal amplitude and stability are gradually declining, which could be a sign of social withdrawal, it might recommend finding ways to get more involved in their community and interact with people more. And finally, if their breathing pattern suggests they might have some sleep problems, it could offer tailored sleep hygiene advice.
So it's really about creating these incredibly specific and actionable recommendations based on what your voice is telling us. This really does feel like a whole new way of thinking about brain health. In fact, the blog post even calls it a new paradigm. What do they mean by that?
I think they're talking about a fundamental shift in how we approach cognitive health. Instead of just checking in on our brains every few years with the cognitive test, we're moving towards a model of continuous monitoring, using something we do every day anyway, which is speaking. And the fact that this kind of sophisticated analysis can be done on devices we already have, like our phones or smart speakers, means that this kind of insight could become much more accessible and affordable than traditional methods like brain scans.
And you touched on a key point earlier, this idea of intervening at the optimal moment because of the brain's plasticity. That seems really crucial, right?
Yeah. Absolutely. The earlier we can detect even the subtlest changes, the better chance we have of using interventions, whether it's lifestyle changes, therapies, or just brain-healthy activities to really make a difference. When we catch things early, the brain has a much greater ability to adapt, compensate, and even rewire itself. And this knowledge that we can gain from our voice, it's incredibly empowering. It puts us in the driver's seat.
I love that. It's all about taking a proactive approach, being in control of our own brain health. Now, at the end of the blog post, they have this call to action, inviting people to join the Vibes tribe. What's that all about?
Well, they're basically building a community of people who are excited about this whole field of voice-based cognitive health monitoring. By joining the Vibes tribe, you get early access to their technology, you can help shape its development, you can even contribute to research by sharing your data anonymously, and you get exclusive updates on the latest findings. It's a great way to get involved and be part of this potential revolution in brain health.
It sounds like an amazing opportunity to be on the forefront of something really groundbreaking. So, as we wrap up this deep dive into vocal biomarkers, what's the main message you want people to walk away with today?
I want people to realize that their voice is so much more than just a way to communicate. It's like a window into their brain, a source of incredibly valuable information about their cognitive health. And by tapping into this information, we have a real chance to change how we think about and manage cognitive decline, both for ourselves and for future generations.
It really makes you think about how much we might be missing, how many clues are hidden in plain sight, or rather, plain sound. I mean, if our voice is constantly reflecting these subtle changes in our brain, What other signals are we sending and receiving every day without even realizing it? It's a fascinating thought, and it really highlights the incredible potential of technology to help us understand ourselves and take control of our own well-being. Thanks for joining us for this deep dive.